Welcome back. This is part 2 of our lesson on solving quadratic equations by factoring. So we need to have 0 on one side in order to use the zero product property. So let's add 5 to both sides to get 0. So that's going to give me x squared minus 11x plus 24 is equal to 0. So now we can go ahead and factor this. X squared will be x times x. 24. Okay, 24 might be 4 times 6, or it could be 3 times 8, or it could be 2 times 12, or it could be 1 times 24. Right? Those are all of the ways to factor 24. Because the leading coefficient is 1, I can start looking for the middle term now. I can only do this when the leading coefficient is 1. So I can either add or subtract. For example, if I add the 4 and the 6, I get 10. If I subtract, I get 2. 10 and 2. Okay, neither one of those is 11. With the 3 and the 8, if I add them, I get 11. Alright, if I subtract, I get 5. But if I add them, I get 11. So this is the only one of these pairs that will make 11. Again, I can only think like this when the leading coefficient is 1. If this was a 2 or a 3 or something, I have to stick with inner plus outer equals middle. But for right now, let's use the shortcuts that we can. So 3 times 8 is the way to go. Inner, I've got 3x. Outer, I've got 8x. I need that to make negative 11. It'll make negative 11 only if both of these are negative. So negative and negative. Now, does that give me positive 24? Yes, a negative times a negative is positive. Okay, so we have correctly factored it. Now we can use our zero product property to find the two solutions. So x minus 3 equals 0, x minus 8 equals 0. Add 3 to both sides, we get x equals 3. And adding 8 to both sides gives me x equals 8. Okay? If the degree is 2, we expect to have 2 solutions. If this were cubic, I would expect to have 3 solutions. Okay? Number 6. Again, we need 0 in order to use the zero product property. So let's get 0 over here by subtracting 5 from both sides. So that's going to give me 3r squared minus 16r minus 12, okay, equals 0. I'm looking for a common factor. There isn't one. So let's go ahead and factor this as a binomial times a binomial. Now this problem is a little more interesting because it has a leading coefficient of 3 instead of 1. So be very careful. 3r squared can only factor as 3r times r. Now on the other hand, 12 can either be 3 times 4, or it could be 2 times 6, or it could be 1 times 12. Now I can't just look at these and look for the 16. Alright, you'll notice that none of these make 16. So some kids think, oh, this is prime. Prime! I have some kids want to put prime for like 7 problems on the test because of things like this. No, it's not prime. It's rarely prime. Guys, if you're taking a test and you're getting more than one answer that's prime, you're probably messing up. Alright? Prime is rare from a teacher standpoint. Anyway, it's got to be we have to check the inner and the outer. So let's just take some guesses. So let's just start with 3 times 4. So as I look at the 3 times 4, I have to decide whether I want to put the 3 here and the 4 here, or the other way around. Well, I would not waste my time on putting the 3 right here, because that creates a common factor inside the parentheses. If there's no common factor in the original problem, there will be no common factor inside the parentheses either. So save time. Don't waste time putting the 3 here. Okay? If this is going to work at all, it has to be 4 and 3. Okay? Time saver. So inner, we have 4r. Outer, we have 9r, because we're multiplying to get this. Okay, we're trying to get negative 16. This most I can make out of this is 13. So that means it's not going to be the 3 times 4 option. And notice I do not try putting it the other way and putting the 3 here, because that would make a GCF. So now we try the 2 and the 6. Okay, 2 and 6 can only possibly work in one direction. Am I going to put the 2 here and the 6 here, or will I put the 6 here and the 2 here? Only one has a chance. I'm going to put the 2 here and the 6 here. This is the only one that has a chance. But one more time, the reason why is because if I put the 6 here, that's going to make a common factor. Both of these are divisible by 3. If the original problem does not have a common factor, you should not have a common factor inside the parentheses either. So I would not waste my time even trying the 6 here. So I'm only going to try the 2 and the 6 option. If this doesn't work, I'm going to throw it out and go with 1 times 12. That's my alarm clock. So inner, we have 2r. Outer, we have 18, because we're multiplying, 18r. We're trying to get negative 16. Is there any way I can get negative 16r out of 2r and 18r? Well, yes, yes there is, actually. Negative 16, I need the bigger one to be negative. So, because I know 18 minus 2 is 16. If I make this a negative 18, and if I make this a positive 2, that'll make negative 16. So there's my positive 2r right in your face. The negative 18 would come by making this a negative 6, because that goes with the 3. One more thing. Am I getting a negative 12? We must check the sign here. Positive times a negative is a negative 12, so that's all good. Okay, okay. So now we can use the zero product property, which says if something times something equals 0, either the first thing equals 0 or the second thing equals 0. Okay, so this is how we will get our 2 solutions. The degree tells you how many solutions there will be. Okay, subtracting 2 from both sides gives me 3r equals negative 2. Okay, dividing by 3 on both sides gives me r equals negative 2/3. I'm running into my next problem a little bit there. Meanwhile, adding 6 on both sides gives me r equals 6. So these are the 2 solutions, negative 2/3 and 6. Okay, let's take a look at number 7. Okay, again, to be able to use our zero product property, we need 0 on one side. So let's subtract 27b from both sides. Now these are not like terms, so I can't put these together and make negative 17b something. I don't even know what you would put because they're not like terms. But I'm subtracting 27b, so those will be gone. I also need to add 18 to both sides to get rid of that. So plus 18. So now those are gone. Now we will have 0 on the right. Okay? Now if I do that, then I have all this, I have these three things on the left, okay? None of these are like terms. So what I do is I just put them all in a row. Alright, so I'm going to have 10b squared and then minus 27b, okay, and then plus 18 equals 0. Okay, they're not like terms, so I just write them side by side. Okay, I see all these numbers. Are there any common factors? Always look for a common factor. Now this is only 2 times 5, and this is not divisible by 2 or 5. So no GCF. So let's get to factoring. Okay, so let's do binomial times a binomial. Okay, now let's be real careful with this because normally we immediately go, okay, this will be 10b and b. That's what happens most often. But that's because this is most often a prime number. 10 is not a prime number, so we have to be a little more careful than that. Okay, this 10b squared over here, it could be 2b times 5b. That would make 10b squared. Or it could be 10b times b as well, 10 times 1. I always start with the smaller numbers first, and I recommend that you do the same because the smaller numbers more commonly happen to be the solutions. I think it's just teacher psychology. We tend to pick the smaller numbers, so use your knowledge of teacher psychology. Okay? Now, having said that, it'll probably turn out to be the other way on this problem. I don't know. Let's just try it and see. Now, look at the 18. The 18 is either going to be 3 times 6, or it could be 2 times 9, or it could be 1 times 18. Okay, again, I always start with the smaller numbers and I work my way up from there. So I will always start with the 3 times 6. And you should do the same if you can. So, fine. Again, notice I'm not looking for the 27 right now. I'm not looking at these numbers and going, which of these pairs can make 27 or negative 27? That only works when the leading coefficient is 1. We've got a leading coefficient of 10. So we have to look at the inner and the outer. We have no choice. So we won't know until we try. So just pick one, write it down, and then check your inner and outer. Inner, I'm multiplying. So inner, I have 15b. Outer, I have 12b. I'm trying to get a middle of negative 27b. Is there a way to get negative 27 out of 15b and 12b? Well, yeah, 15 plus 12 is 27. So negative 15 plus negative 12 will make negative 27. So it looks like my teacher psychology is working for me on this particular problem, which I had never done before, by the way. But by picking the smaller numbers in both cases, we actually got the right answer on our first try. Okay? So it's all about the tricks. Let's check one last thing before we go on. We have to make sure we're getting a positive 18. Does this make positive 18? Sure. A negative times a negative is a positive. Yawning. Okay, so this is correctly factored. So now we can use our zero product property to find the solutions, alright? Either this factor equals 0 or this factor could equal 0. So I'm going to do that up here now. So either 2b minus 3 equals 0, or maybe 5b minus 6 equals 0. So adding 3 to both sides gives me 2b is equal to 3. Okay, now dividing both sides by 2 gives me b equals 3 over 2. Okay, meanwhile up here I can add 6 to both sides. So that'll give me 5b is equal to 6. And then dividing both sides by 5 I get b is equal to 6/5. Alright, so these are the two solutions for number 7. Okay. This video is getting long, but we're almost done, so I'm just going to power through, and it's just going to have to be a slightly long video. Okay, so number 8. Okay, a nice simple one. Alright. Whoever created this document keeps putting plus minus. Quit it. Okay, and it even has 0 already done for us. So, alright, this is going to be an extra easy problem. Okay, so we can immediately factor. So this will be y squared is y times y. 21. Okay, the first thing that pops into mind is 3 times 7. So that's looking good. Inner we have 3y. Outer we have 7y. We're trying to get a negative 10. So a negative 3 and a negative 7 would make negative 10. That means both of these would have to be negative. Hold on, I can't see properly. Is that giving me positive 21? Sure. Negative 3 times negative 7 is positive 21. Better move this out of the way. Okay, so now I can use my zero product property. Either y minus 3 equals 0 or y minus 7 could equal 0. Okay, if adding 3 to both sides gives me y equals 3. Adding 7 to both sides gives me y equals 7. So those would be the solutions. Okay? Yeah, you get it. You got it. Finally, number 9. Error analysis. Look at my work below. Look at it. What happened to the 5? Okay, so you see what they did there? And in fact, you can imagine what step came before this, right? The original problem was probably 5x squared minus 5 equals 0. So they pulled out the GCF, okay, and then they took this, x squared minus 1, that's the difference of two squares, so x minus 1, x plus 1. Alright, but then they set x minus 1 equals 0 and x plus 1 equals 0. But what happened to the 5? Well, there's two ways you can think about it. One way to think about it is you could, at any of these 3 steps, you could divide both sides of the equation by 5. You could have done it at the beginning. You definitely could have done it here. Alright, get rid of that 5. 0 divided by 5 is 0. Okay, but you could do it now. If I divide both sides of this equation by 5, this is perfectly legal. Okay, then these 5's cancel out. So that could be one explanation. We divided both sides by 5. Okay, so the 5 is gone. That's one way to think about it. Here's another way to think about it. Logic. According to the zero product property, if you have several factors multiplying together and they all equal 0, you know, like if I had A times B times C equals 0, well, then either A equals 0 or B equals 0 or C equals 0. Alright, so here I have these three factors. I have 5 and then I have the two parentheses. But if I set all three of these equal to 0, then that would be saying that 5 equals 0. Right? If I included the 5 in this process. If I said 5 equals 0, or x minus 1 equals 0, or x plus 1 equals 0. This one doesn't make any sense. 5 does not equal 0. Okay, so we can disregard that as a possibility. It's not a possibility. Okay, 5 cannot equal 0, so disregard it. Okay, ignore it. That means ignore it, if you don't know what disregard means. So you could look at it as either one of those two things. Alright, this video is already slightly longer than I like, so let's wrap it up. That's the end. I hope this was helpful to you guys. Thanks for watching. I'll see you on the next video.